Hello everyone, welcome to day 26 of 30 days of KNIME. I apologize if the audio sounds a little bit off today. I'm using a different computer. So today I'm going to be showing you the Normalizer node, and I'm not showing you that on the airline's data because I don't really see a very good application. But I literally use this node today for a use case, so it's a perfect day to show you this. When you are dealing with variables of different scales, it's usually good to normalize them because having a variable that is way larger than another one could influence your model and could add some noise to your model. Also, when it comes to visualization, it's hard to visualize things that are miles apart in terms of their scale. Now, let's go here and look at. Here I have the GDP of Qatar since 1992, as well as the US imports into Qatar. The US imports is in tens and hundreds, whereas the Qatar GDP is in billions, and even up to hundreds of billions. Now, this is way larger than this one, and if I try to make a graph of this, this is what that looks like. Now, when we open this up, we can see the GDP, but notice how the US imports is a flat line. This is because the magnitude of this is so tiny in relation to this one, you can't see any trends down here. Now, if we normalize this, let's just move that over here. Now, if we normalize this, we'll be able to see trends as well as how those two variables move in relation to each other. Opening up the normalizer node, you can include the variables you want to apply the normalization for. You can use the min-max normalization. You can use the z-score normalization, which is my preference because I am a psych major and we live and die by the z-score. And you can also normalize by decimal scaling. If you have flow variables, you can specify those here, and you can also control the memory policy. It's a very straightforward node to configure. So once we run this, okay, now it has been normalized according to the z-score. The z-score changes how the number looks like, but it does not change the deviations or the magnitude of changes from one year to another in your data set. Now let's drag another line plot and we'll be able to see something more useful. Now we go to view this and we can see that both variables are now in a way that you can plot together because they have been normalized. Here you can see, if you're familiar with Qatar, you would know the blockade happened in 2017. And you can see from that point, US imports skyrocketed because we became more interested in importing US products for reasons you know if you're familiar with. But also, the GDP of Qatar did go up during that period. And then, of course, in 2020, we had a decrease in GDP as well as a decrease in US imports. And this was largely due to the COVID-19 pandemic. So having normalization allows you to put your variables in a way that you can view them together versus what we had as a flat line before. Now, to prove to you that normalization does not change the patterns of your data, look at this GDP graph. Notice that there was a steady rise from 2009 up until 2014. If we go to the original graph before we applied normalization, you can also see this exact same pattern. 2009 up until 2014, you have that same rise. I'll put in some resources to study the z-score and what it does, but this is a technique that's very important when you want to build models. You don't want to have an issue where the scaling influences your model and adds noise to that. This is something you can overcome using the normalizer node in KNIME. All right, guys, have a lovely day. I shall see you tomorrow. Goodbye.